You know, I was actually reviewing the previous video. Do you remember the scene where my chair got stuck between the two poles? The great thing about this, I need to lose weight. I think I really need to lose weight. I was actually checking out a bit of a belly in that video, so I'm actually now on shredded wheat or Weetabix for my breakfast in the morning now. So I don't know. It's what you get when you become lazy. And also reviewing the actual video, and I mentioned the 3 technologies that Google develops, and actually didn't mention their name. I was actually going to pretend that was a feature, like you know when you actually watch a TV series and you know it's like part 1 and it goes dun, 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 get ready for part 2, you know, for the conclusion. Yeah, I was kind of thinking of fobbing off the previous one as I didn't intentionally forget. I was going to be surprised for the next one, but hey man, hold my hands up. I actually forgot to mention the 3 technologies. So anyway, I'm going to mention it now. So the 3 technologies are basically the Google file system, so that's for distributed storage. We have MapReduce, so that's distributed compute, and we have BigTable. So they're the 3 technologies that Google developed in order to help in search, distributed search, which basically is what Google is all about. Okay, so let me step through those 3 points again. So they first scrape websites, and that data is then stored. So that's where the Google file system comes in. The data is stored within the Google file system. The data that's stored in the Google file system is then processed. So they obviously try to match a search term like Hadoop to a list of links to all the pages that's actually been searched. That result, okay, so that's the MapReduce, that's the computation part. But then the result of that needs to be stored in another system, and that's BigTable. And BigTable really is a key value type store where key, so Hadoop, value, the links. Okay, so basically when you go to Google and you then do a search, you're not going through the whole it's scraping and computing and then indexing at that point. No, the scraping, the computation and the indexing has been done already. So when you actually do a search, what you're really doing is looking at the BigTable. You're looking at the key, list of values a value comes back, which is a list of links, and that is what's presented to you. Now, this is very old technology in terms of the Google file system, the BigTable and MapReduce. They also use something else today, because obviously they're scaling out and they have a better way of doing it. So this is almost like the 3 technologies I just mentioned to you now. It's like version 1. Okay, and the group at Yahoo then, let me roll back a bit. Google then wrote 3 papers based on the 3 technologies, and the guys at Yahoo obviously looked at these papers and decided, let's implement this, and that's what they did, and that's where Hadoop was born. Okay, so yeah, apologize for that. But what is the topic for this particular session? In this session, I'm going to look at what Google would have done before they came out with the Google file system, BigTable and MapReduce. How could they have implemented how could they have implemented a scalable solution pre-Hadoop or pre these 3 technologies? Because some organizations may say to themselves, we don't want Hadoop, it's too big. We want to stick with what we know, which is basically relational databases, transactional relational databases, and can we scale that in such a way so that we can continue utilizing this? Because all the knowledge base is still with our guys. We know databases, we don't know Hadoop. Can you help us out, Toy? So I'm going to do a diagram in terms of an implementation of how you can potentially scale data or data access for loads of users. Okay, I'm going to whiteboard this. I need a marker, which is somewhere. That should work. I need a cloth to clean the board. This should do it. most importantly, I need my cup of tea. So this is a potential model that one can utilize if they actually want to avoid the entire Hadoop ecosystem. So what you can do yes, so in summary, you can have multiple databases clustered together. Okay, I'll actually put a triple dot here to signify that it's actually not just three. You can have a cluster of databases. Okay, these databases are connected to a switch, and this switch is then connected to network attached storage. I'm not going to talk about the form of this storage because it could be SAN, it could be NAS. Yeah. So again, this is very, very high level view. So network attached storage. Okay, we have a switch that knows how to cope with storage data. So this is a switch that knows how to pass storage data around. Here are your databases. So this is used to talk to your storage backend. Here's another switch. This switch is used for the internal communication between these databases, because these databases have to have the same view of the data here. So this database has CPU, or I draw it here, but it's the same for all three databases. So basically you've got CPU, processing, okay, and you have memory. But the disks that is stored on this, so this is a server, right? So the disks stored here, here, and here is for the operating system, not to house data. The data is stored externally on this external structure here, okay? So these three are then connected to this switch. This switch is used for inter-database communication, so that these databases have the same view as the data, or of the data here. Okay, so if somebody comes through here and via this guy you update records in your database, these guys have the same view. Now you can see as you start adding more and more databases, because you have to have the same view of the data here, the question is this linearly scalable? So hence, if you just have 3 servers in this model, okay, and that can handle 1,000 users, so if each time you double the actual number of databases, can you double the number of users that the system can actually handle? And if this type of model, the answer is no. At some point, adding more servers won't actually add anything to your system. In fact, it could start to slow the system down. And in a future video, I'll actually draw a diagram of that. So what are these 3? So AS stands for application server. Application server. Now, looking at this model, I would actually break this up and put another switch in here. So basically, we have 3 switches. So this is the if you really want an official way of doing it, these 3 switches. This one, again, is the data. It's a switch for the back end to connect to this storage area here. This switch here is for inter-cluster communication for the database itself. And this switch here is for the application server. So this will provide public IP addresses, for these guys. And these are all like internal, private to the organization. So yes, so if one wanted to try to avoid the whole Hadoop ecosystem, and when I say Hadoop ecosystem, this also includes the whole NoSQL as well, and in-memory databases. You want to stick to what people already know. Databases. This is one approach that you could potentially use to scale out from one database alone. So instead of one database serving the entire company. You can now utilize multiple databases and have this type of cluster in front of it. So this gives you like this will give you a type of like even though this is a cluster, the client out here still sees the cluster as like one database, in fact. But internally, it has special software to actually try to scale this out. Again, a very small scale, this will kind of work, but as you start to scale out, this will be no good. So I guess that this is the model that Google tried to do at the beginning, or Facebook tried to do at the beginning, to try to scale out. And again, it just didn't work. Okay, so then they had to do something from scratch. And so the new architecture, which is based on the Google file system, which the commercial version, or I should say the open source version, basically is HDFS, and then you have the MapReduce, and again the actual open source version is also called MapReduce, and there's a new implementation of that called Yarn. So again, we'll talk about that in the future. And then we have BigTable. So I talked about BigTable in terms of the key value store, and the open source version of that, which is part of the Hadoop ecosystem, is called HBase. Okay, so they're the three terms. Those systems are in use today, and they are packaged up by the Hortonworks and the Cloudera and the Mapr companies of this world, and they also have open source, not open source, but there's virtual machines that they have created that you can actually download for free and actually play with this on your own hardware. And in future videos, I'll be actually going through that myself and showing you, how this stuff works. So, pre-Google file system, pre-MapReduce, pre-HBase, this is something that you may want to try. Okay, be expensive for you to try it, and I suggest you kind of try it on a laptop virtually. That's a model you may want to try out. May work for you, may not work for you.